Hello everyone, it is 8:42 p.m. Wednesday, June 25th. And we're going to continue on with our coding. So we started graphs yesterday, did a number of islands, which I remember being an easy problem, but it was getting a little bit of issues, but I think that's also because this is my first time touching graphs in about 8 months. Last time I did a graph question was when I did it for my interview for my current internship. So that was back in October. It's been a minute. You get back into it. So you're given a m by n binary matrix grid. An island is a group of ones representing land connected four directionally, horizontally, or vertically. You may assume all four edges of the grid are surrounded by water. Return the maximum area of an island in grid. There's none. Return 0. So 6. It's pretty simple. Yeah. Okay, I think this is pretty simple. So first we're gonna do a checked array for row in range length. Actually, I don't need that. For row in grid, checked dot append a row, and then for column in row, checked dot up checked. Oops. Nope. I do need it. And length grid, and then we'll do range. Yeah. Here I don't need to do that though. Nope. I do need to do that. Honestly, probably would have just been easier to do it in array, I'm not gonna lie. Okay. Just to check this works, we're gonna do that. While that's running, I'm gonna go ahead and start writing the next stuff. Oh. There we are. Okay. So then I'm going to take in row and column. And I'm going to make it return an integer. So, if row is, you know what, I'm not gonna lie, it is the 25th. It's the 25th of June, so I need to update my resume, like, now. Because I think the jobs that I'm going to be looking for are going to be opening up pretty soon. row is greater than or equal to rows, or row is less than 0, or whoops, rows, or column is greater than or equal to columns, or column is less than 0. Okay. So this is, I'm going to say this is out of bounds. I'm going to write multiple if statements just because I think it's cleaner. We'll return 0. If checked of row a column, or grid of a row column equals, is it an integer? It is an integer. Equals 0. Then return 0. Right? Okay. So that's our edge case. And then I'm going to say top, down, left, right, and then I'm going to return 1. I'm going to return 1 plus top plus down plus left plus right. Okay. So top is going to equal DFS of row plus 1 column. Down is going to be DFS of row minus 1 column. Left is going to be DFS of row and column minus 1. And right is going to equal DFS of row and column plus 1. Okay. So that's all I need to do in the DFS. I don't really need to track maximum in DFS. DFS is only going to be a function that pretty much that just actually gets the value for me. Max will be tracked outside, so say max count is equal to 0. Return max count. Okay, and enumerate. Sorry, grid, yep, and then for column index and column in enumerate row, it's probably more like element. Okay. I'll do an if statement. If checked of row index, column index. And grid of row index, column index is equal to then I'll do my DFS of row index, column. And gosh, these problems are so much writing. Okay, then count equals that. Jesus. Or I'll say max count equals max of max count, or let's do like forearms and shoulders are like tensing up and getting sore from doing this. This is ridiculous. It's probably gonna have an error. Yeah. Oh, you know what? I know what the error is. I did this error last time too. You have to actually track that you seen it, so that way you don't just keep endlessly going into a circle. Let's see. Hopefully that works. Okay, the problem was pretty self-explanatory. It's just the last problem, but just a maximum on top. Cool. Okay. Clone graph. All right. So given a reference of a node in a connected undirected graph, return a deep copy clone graph. Each node in the graph contains a value integer and a list called list node of its neighbors. Okay. Original graph. This looks like a clone. The nodes are new. Graphs look the same. Can't return the same graph. Nodes are cloned, but the graph is messed up. Doesn't have the same connections. Okay. I feel like I'm gonna do a botched solution. We'll see. Okay. So I'm gonna do DFS. I'm gonna do. I love DFS. I'm not gonna lie. DFS is like low key my favorite. I remember years ago I was watching what's his name, Prime Time or something like that. He was saying like, oh, DFS like the one algorithm like you'll never forget. And this is when I was taking my data structures class, which I know is kind of interesting because like, typically people don't say years ago for that. But yeah, years ago I took that class. It was back in 2022. No, 2023. My apologies. I remember doing DFS and I hated it. And there's like, there's no way I'm ever gonna like this. But whenever Primetime was talking about that and how it's like the very nostalgic for him now, he would never forget it. As I've gotten older, I'm like, yeah, this is actually a pretty good algorithm. It just works. Now Dijkstra's and that stuff, that's where it gets a little finicky. That's where it gets a little interesting. I gotta relearn my Dijkstra's because I don't remember my Dijkstra's. I'm wondering if there's going to be a Dijkstra's problem, or a Prims, or a Kruskal's. Probably. Gotta go look back into that. Maybe if I can go reconnect with my old algorithms professor, see if he can give me a quick lesson. Okay. I'm gonna call it current node. Hold on. Sorry. Family's yapping downstairs. I don't know if that's probably getting picked up with the mic. And it's hot in my room, so I'm looking the fan on. You're back. Okay. What am I thinking here? Basically what I'm thinking is we just do DFS and then in the place we just kind of copy the node. Right? And then we return the node. So the beautiful thing about the way the neighboring system works is we can kind of like check it kind of differently than how we were checking it last time. Last time we didn't check if the neighbor was valid before doing a recursion. This time we can actually check it beforehand. So we're gonna dude, oh wait, actually this is a real graph, and I'm not gonna lie, I forgot how we actually track if it's been found or not. I'm guessing value has to be unique in my instance in order for me to do that, but like that's not that's not the right way. Crap. Okay, well I think in this instance value is unique. Okay, I'm gonna do checked is equal to a dictionary. Then I'm gonna say checked of current. Sorry. Yes, we'll do current node dot. No, we can do that because we're not ever actually checking the cloned. I'm gonna say equals true. Okay, and then I'm gonna go check the neighbors. I'm gonna say for the neighbor in current node dot neighbors. Wait, what? Oh no, okay. I just. I was say, what are we talking about? If neighbor not in checked, which is good, that means I can run DFS on neighbor. Okay, and that's like kind of low-key it. From if I'm like doing this right, I'm pretty sure that's it. So what I mean by that is I haven't done my cloning yet. So this is where it kind of changes. I'm gonna return node, okay, but I'm not writing that out. I'm gonna say cloned node equals node. Is it like new node? Like new node? No. Node, and then we're gonna do the value is gonna basically just be current node dot value. We're not gonna do neighbors. Honestly, hold on. I don't trust that none thing. The kind of I don't like that. Dot append that, and then we just return a cloned node. Let's see it. I don't know. What type of error? Oh, yeah. Dot neighbors. None type object has no attribute value. Huh. None type. Why do you have a none type? And neighbor. I mean, none type object has. Okay, I will say if current node, if not current node, print error, there is a null, and then just return I don't even know, return node of 0. Wait, then, hold on. Wait, what? Where am I airing out? Here I'm airing out. Okay, I guess. Sure. That's kind of an interesting edge case. Okay, cool. So okay. I mean, yeah, whatever. Sure. What's happening here? Two, three, four blank. So this my algorithm is not working at all. By the looks of it, it's not even creating any edges. As the edges have to be doubled, huh? But you know what? Fuck. How do I? I have an idea. I have an idea. This is this is kind of a dumb idea. A little bit. that work? Okay, so the issue I was running into, basically, if it was checked, then it's not going to do DFS, which makes sense. That way you don't get into an infinite loop. The error is that it's still technically a neighbor, so that needs to be added to the registry for making a copy. Yeah, nice. And also the faster side of the situation. Very cool. I'm curious to see if I have the right idea. Yeah, that makes sense. Cool, so I did that exactly how he did it. Nice. Which means I did it the standard way. Oh, come on. I need to do this problem in his editor. Does he allow me to do that? I did it one time. Where's that? Oh! Sorry, I just blinded us. How did I do it that one time? Dude, I remember doing it one time. It was on this one. I did this one. How did I do it? Solves. How did I do it? I'm so confused. Aha! Aha. Okay. I'm an idiot. Cool. Alright, this is the last one I'll be doing today. No? No, was that? Hold on. Wait a minute. Walls and Gates. Islands and Treasures. He renamed it. Copyright. I'm given a M by N 2D grid that is initialized with these three possible values. It could be initialized with -1, which has, oh, I see. The element could be -1, which is a water cell that can not be traversed. 0, which is treacherous, and infinity, a land cell that can be traversed. Why not just use one? I'm so confused. Fill each land cell. Maybe there's a reason for that. Fill each land cell with the distance to the nearest treasure chest. If a land cell cannot reach the treasure chest, then values should remain. That's a really cool problem. This is a really cool problem. Okay, I like this idea. I don't think it's too challenging though. We'll see. I mean, it's gonna blow up in my face, but the way I'm assuming this is basically we keep digging until... Wait, okay, no, this could be challenging. worried about is like initializing a value with something and then like it getting stuck with the wrong value. It's like I needed to pass it almost. Like maybe I can double pass it by going through recursion. So you touch it while you're going down, and then you kind of see it again while you're going back up. We'll see. I'm gonna make a checked array, and then I'm gonna say for index row and enumerate grid, and then I'm gonna say for column and enumerate no, I'm saying for column in row. Say checked index dot append false, and then over here I'm going to say checked dot append an empty array. Okay. Check is now initialized. I'm gonna do this as DFS. I mean, realistically, it kind of always plays out to be DFS. Oh! But this is not DFS. Isn't this cross count? No. Bro, no, this is like actual algorithms. Oh no. I think oh, okay. Wait. That's actually pretty. That's a good idea. What the hell? That kind of just gave away the problem. Okay, but I do need to take some time and study up my Kruskal's and whatnot. Because isn't that what Kruskal's is? It's like the distance away. Okay, so now I'm gonna go through. I'm gonna do basically what he suggested, which is I think is pretty smart. If element is equal to, it's an integer, right? Cool. Now I'm going to do a checker. If row is greater than or equal to a length of grid, or row is less than 0, or column is greater than or equal to length of grid 0, or column is less than 0. Out of bounds, so just return, just return. If it's water, so if it's if grid of row column is equal to -1, return. That's water. Basically, I'm gonna have to repass through if if it's smaller, because I have to check it. Because like you could have, for example, like maybe this value right here is like 10, and then this value here is like 9 or whatnot. Let me find this. Okay, well then this gets turned to 1, and then I need to go up here and then you change that. So. Okay, so we check it, say, hey, we've been here. I'm gonna say that grid of row. Honestly, do I even need checked? I don't, but I already wrote it. It doesn't matter. I can refactor that if I really need to. Check actually does nothing for me right now. Oh, checked. Actually, that's checked is valid for one instance, and from the zeros. You can kind of get into an infinite loop without it. I don't think this will work. I think there's gonna be an error in this. What's my error? I'm missing. Oh, distance. Right. That will do it. Distance plus 1. Because, you know, it's getting further and further. And did I forget the distance here? No, I had the distance here. What's my problem now? Limit exceeded. I don't know why I have that. Just run like that. Oh, hold on. That, sorry. You must have been wrong. I'm sorry, do I not return anything? Did I just print grid? Oh! Huh. Okay. It's just built-in check script. So this is just a mutex, or whatever the terminology is. Nice. Okay, what's the problem here? Now it's viewable. We replace the distance. Fuck. We replace the distance. Just get rid of this junk. I don't need this. Actually, let me just comment out just in case I do need it, but I don't think I do. I think I don't need this at all. I'm gonna say distance equals the minimum of distance and current grid. I'm gonna run that. Hey! Dude, the checked array is dog water. It is useless. Not even needed. Get rid of it. It's trash. It's trash.
Dude. Sweet! Nice. Peak, brother. Peak. Alright. Cool beans. That was 3. Which is all I'm going to do today. 72 out of 150 complete. So it's been almost a month.
I gotta check. I'm trying to recall if I uploaded yesterday's video. If not, then yesterday and today's video are gonna be uploaded at the same time. LOL. Anywho, it's been almost an hour. So thank you for watching, and I will see you tomorrow. Bye bye.